So we never have an excuse when we're asked to graph. We can always make a little xy chart. Let's see what's happening here. 3 to the 0 is 1, so 0, when x is 0, y is 1. 3 to the 1 is 3, so when x is 1, y is 1, 2, 3. 3 squared is 9, so when x is 2, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, it's getting big. It's getting big exponentially. Let's see what's happening on the other side. When x is negative 1, this will be 3 to the negative 1 is a third. 3 to the negative 2 is a ninth. 3 to the negative 3 is a 27th. 3 to the negative 4 is a 64th. It's getting smaller and smaller and smaller. But no matter how many times I multiply 3 by itself or divide by 3, I'm never going to get it to be negative, and I'm never going to get it to be 0. So we get an asymptote here at y equals 0, because it'll get closer and closer and closer and closer. It'll approach 0, but it won't touch it when x gets really, really small. So we have our lovely basic exponential shape. It gets big very fast. There you go. And so now you can take that basic shape and shift it using all your normal transformations. So if I have y equals 3x plus 2, that'll just hike the whole thing up 2. So my asymptote, instead of being at y equals 0, will be hiked up to y equals 2. And every single point will be shifted up 2. And so I end up getting this shape there. And then if the plus 2 is grouped in, it'll shift it, shift the x, shift horizontally, and shift it the opposite way you'd expect it. When it's grouped in like that, it needs to be undone. So this is going to go left 2. So every point will shift to the left 2. So that point goes left 2, that point goes left 2, this point goes left 2, and you end up getting this lovely graph. And the asymptote for that one is still y equals 0. It wasn't shifted up or down, so it'll still eventually get to 0. It's the up and down part that's going to control where the asymptote is for these guys. If it hasn't been shifted, it'll always just be at y equals 0. Cool. That's that. What else do I want to say? Oh, a couple other notes. So if you saw y equals negative 3 to the x, remember your normal one looked like this, and so y equals negative 3 to the x, that just does your normal flip this way. So that'll be that way. And if you see y equals 3 to the negative x, that's your flip that way. So that's what that would look like. Notice that this is the same as 3 to the negative 1 to the x, right? Those powers are multiplying. This is the same. And 3 to the negative 1 is 1 over 3 to the x. So when you have a base that's smaller than 1 here, you end up getting this decay function, this exponential decay, and it ends up decreasing instead of your normal exponential growth when the bases are bigger than 1. So, good to know.